Let's take a look at this question now. Um, it's a rational function question. It says that the curve C has this equation and state the equation of the asymptotes. Now, it is a fraction in which the highest power of the numerator is the same as that of the denominator, which means that I can say that there is going to be a constant. I mean, there's going to be three asymptotes. Two of them on the two of them parallel to the y-axis and two of them and one of them parallel to the x-axis. If this was larger than what it means, that means that this whole thing will be improper. Then it means that the curve would have to have an oblique asymptote. But in this case, it is constant. I mean something like y equals to c. I mean something like y equals to 5, x equals to 3, x equals to 2, something like that. If they, I mean, yeah, anyways. Okay, so before I continue ahead, I just realized while editing this video that this video is like 30 minutes long. Yeah, 13-mark question. It are also rational functions. Rational function topic itself, if you're talking about the asymptotes, intersection with axis, and then we have the stationary points, these things together, it takes quite some time to find them together and make sure that you get a proper sketch of a curve. So obviously you would expect this topic to be quite long, like about 15 to 20 minutes, especially because this is a 13-mark question. But I just ended up spending extra 10 minutes on explaining things about this topic because obviously this is my first video on this topic in this channel, rational functions. So yeah, I apologize for that. For now, let's just get back to the video. First of all, for this part, I have to write down the equation of the asymptotes. Asymptote equation. So first of all, we have x square minus 2x plus 1 equals to x minus 1 whole square. And if we rewrite this thing in terms of your partial fractions, then we have 2x square minus 3x minus 2 by x square minus 2x plus 1. This is something you'll be able to do in a jiffy, but the trick is to divide this by this, but I would not recommend that. This can be written as equals to a by x minus 1 plus b by x minus 1 whole square. So we have a into x minus 1 whole square plus b x minus b. So we have here ax square minus 2ax plus a plus bx minus b. So we have a minus 2a, actually 2, a equals to 2, b equals to, hold on, not this way, not this way. Actually, there is supposed to be another constant at the front. Or you know what, instead of doing this whole nonsense, I can actually try to do long division. Long division is much easier for, okay, long division is much easier for the partial fraction thinking. I mean, this sort of thinking. Let me show you. So in this case, what I have is 2x square minus 3x plus, no, minus 4x plus 2. So we have only x. So the fraction looks something like this, 2 plus x by x minus 1 whole square. So in this case, what I have to do is that I have to write it down like it is not minus 6 plus it's minus 2, x minus 4. So as a result, the asymptote will be x equals to 1 and y equals to 2. I'll keep this in mind. Then we have in part B, show that y is less than or equal to 25 by 12. If it says to show an inequality on y there, I mean, if I have to show an inequality on y, then what I have to do is that I have to rewrite this equation in this way. Yx square minus 2yx minus y, I believe, no, plus y, this equals to 2x square minus 3x plus 2. No, it's minus 2. Then I take this to the other side, so we have a y minus 2 x square plus 3 minus 2y into x plus y plus 2 equal to 0. So what I want to say in this case is that I want to have such a scenario so that b square minus 4ac is always greater than or equal to 0. For any value of c I have, I want to make sure that if there is always a solution to this equation right here, this equation, where I could easily draw a graph, then I have to make sure that there is always a value of x for which I can get a value of y. So I need to deal with that here. So for that, because I want to always have a solution, b square minus 4ac equal to 0, sorry, greater than or equal to 0. So then we have 3 minus 2y whole square minus 4 y minus 2 y plus 2 is greater than or equal to 0. I hope it's correct. We have 6 minus 12y plus 4y square minus 4y square minus 4 greater than or equal to 0. 6 minus 12y plus 4y square minus 4y square plus 16 greater than 0. Then we have minus 12y plus 22 greater than 0. Oh no, it is not 6, it's 9. 9 plus 16 is 25. Then we have 12y less. If we take this 12 to the other side, then we have a 25 greater than or equal to 12y, 12y less than 25, y less than 25 by 12. I mean, solutions must exist. I want such values of y. Next, find the coordinates of any stationary points of C. So for this one, I just have to differentiate. Okay, see, differentiation is a bit lengthy, especially these sorts of quotient things. I mean, division fraction things. So if we have y equals to 2x square minus 3x minus 2 by x square minus 2x plus 1. Then we have dy dx equals to something like this. This times derivative of that minus this times the derivative of that divided by this thing whole square. So if I equate this to 0, then this means that this whole thing, this thing becomes negligible. Equate this to 0, this thing becomes negligible. So this means that we have something to deal with here. Okay, we have 4x cubed. Isn't this a bit too lengthy? Because I have a cubic here, then also for 3 marks. Yeah, it's 3 marks, and I have a sort of a cubic. Where's that? A cubic here. Okay, let's see what you have. From there, I can reduce things. Otherwise, I could No, I cannot. I cannot take anything common out of here. So I have to do cubic. Minus 6x squared, 4x cubed minus 6x squared, plus 4x minus 3x squared, plus 6x minus 3, minus 4x cubed. Okay, actually I don't need to do cubic because I realized that I can cancel these two out. Minus 4x cubed, minus 6x squared. Actually, I can cancel even more. Plus 4x. What? Minus 4x squared plus 6x plus 4. I can cancel a lot of things here, actually. 4. Oh, it's not 6, it's 8. 8, 4. Then we have this equals to 0.
Then I'll just solve this equation, so I'll fast forward, I'm fast forwarding maybe. Plus 6x squared minus 4x plus 4x squared minus 6x minus 4 equal to 0. This gets cancelled out. This gets cancelled out. This is minus 8 plus 6, which is 10, so we have a 2. I'll deal with that later. And here we also 3. So it's minus 11 plus 10, so we have a minus x squared. This is dealt with. 6 minus 6 is 0. And then we have a minus 7. Yeah, minus 7. Plus 3 plus 4. Minus 11 plus 10, it is minus 1. I cancelled these two out. I cancelled these two out. I cancelled these two out. So, let me just take the minus. 4x, 6x. Minus 4x, so it becomes plus 4x, right? Yeah, it's equal to minus, right? Then it's supposed to be here plus. Then this means that it is supposed to be 8x minus 7 equal to 0. So it means that you have x squared minus 7x minus x plus 7 equal to 0. X minus 7, actually x minus 7.
Minus 1x minus 7 equal to 0. This thing, then we have here x equals to 7, x equals to 1. From here, what else do you say to find the coordinates? So actually, it's a bit too much of a work for 3 marks, to be honest. They could have added an additional mark, but I don't think they expect too much in, especially in further maths. And also, this is an old paper. Well, actually, let me tell you something. This is x equals to 1, right? Let me go back to the top. Haven't we declared this as asymptote? In fact, if we substitute this one here, because yeah, it said to find the coordinates, this means that if we put this x equal to 1 here, we realize that we have a x minus 1, so this will become 0. I don't know why we got here 1. So it's always an important thing to check with your thing right there. Even if you use a differentiation function, it's not going to easily work. The best idea is to also check it with your normal function here, with your calculator, if you get a value or not. Because you have declared x equal to 1 being an asymptote, which means that x equal to 1 is not applicable here. So if x equals to 7, then y equals to 98 minus 21 minus 2 divided by 49 minus 14 plus 1. We have here 98 minus 23, which is 75. And here we have 39 minus 49 minus 13, which happens to be 36. 75 and 36. So 25 by 12. Next up, sketch C, stating the coordinates of any intersection of C with the coordinate axis and the asymptotes. Now, this is the most important part. Now, when it comes to sketching a curve, the most important thing for the rational functions, all right, if we have such an situation like this, where we can actually have only horizontal and vertical asymptotes, there are actually 5 important things that we need to know here. First of all, we have vertical asymptotes, horizontal asymptotes, coordinate axis intersection, stationary points, y coordinates before and after asymptotes. Actually, it's immediately before. What it means is that I'll first of all do these three, because these three are very simple. So first off, I have my vertical asymptote. My vertical asymptote happens to be y equals to 2. Then we have x equals to 1 being my horizontal asymptote. So vertical asymptote is complete. Then we have horizontal asymptote. Horizontal asymptote is x equals to 1. No, right. Y, this is x equals to 1. Sorry. This is x equals to 1. That is y equals to 2. So x equals to 1. Y equals to 2. Coordinate axis intersection. So if we put if we put y equal to 0, then we get 2x square minus 4x plus x minus 2 actually. Two x minus 2 plus 1 x minus 2. So x minus 2, 2x plus 1. So it means that this is x equals to 1, x equals to 2, and x equals to minus half. These two are my axis intersection. Then we have, no, actually, x-axis intersection. Then we have y-axis intersection when we have this equal to 0. When this thing equal to 0, then it means this is 0, this is 0, this is minus 2, and this is 1. So it means that it will cross through y-axis at minus 2. Let me check again. 0, 0, minus 2, this 0, 0 plus 1. So yeah, minus 2. So coordinate axis done. Stationary points. Only one stationary point, which happens to be this one. Which one? These two. So 7, 25 by 12. 25 by 12 is roughly more than 2, so we have to put it somewhere here. All right. Okay. So these four are easy. Number 5. Y coordinates immediately before and after asymptotes. All right. Or x coordinate immediately before and after asymptote. So what happens here is that, or x. Now, if I have only this much information, this intersection, these two stationary points, then let me show you technically what my graph would eventually look like. Would technically look like. Now, because I have a stationary point here and an axis there, I don't actually exactly know if I could finish calling it like this. In fact, let me check if it intersects with 2. I don't think it does. I don't think it does. When this equals to 2, then I want to check if there is any intersection. I think there is. I think there's only one. Okay, so now if I have some things at the bottom like this, then my graph could technically start off from here, go through these lines, and then go all the way down towards approaching the asymptote here, which is fine. But I don't think there's any extra way that this could cross these two and go above this thing. Otherwise, what you'd see is that if there were not many other information given, it could cross through here. It could cross through here, or it could cross through like this. Sometimes we notice even the graph crossing to the asymptotes once or twice. All right. So we have to be careful about that as well. And if you have something like this, I expect the graph to go something like this, which is also likely. So as a result, I have to see the values of y I get immediately before this, before and after this one. Value of y before this one and value of x before this one. So let me show you. How do I show this, by the way? Okay, I actually have to use my calculator for this. Give me a moment.
One eternity later.
Okay, here's my beloved calculator here. So if you go back, what I really want to deal with here is, I have here x equals to 1, sorry, x equals to 1 and y equals to 2. I'll substitute, I'll put, first of all, input this equation here first. Okay, now what I want to do is that I want to substitute. I know that at this point is x equal to 1. What if I try to put x equals to 0.99999, which means immediately before this one? Because if I put something here, I'm going to get an error. So if I put here calc 1 math error, which is why I would not make this work. Calc 0.99999, I get minus 3 into 10 to the power 10, which means a very big negative value. So this is one thing. Next up, I want to check what I get if I put this thing, if I put x equals to 1.00001, which means a very small difference between between this one and that. So I can see where the y coordinate is. So calc 1.00001, oops, minus 2.999 into 10 to the power 10, which means it's also a negative value. So it means that my curve so far looks correct. Approaching negative, I mean, trying to approach the asymptote or leave the asymptote, but does not touch the asymptote. And then it also goes to this point and then this point there. Um, hmm. Something feels wrong, because if this curve has to intersect twice, I mean, if the curve had to intersect with the axis, then it would obviously have to cross through 3 points here. But we found out from our equation that it does 2, not 3. In fact, we verified. Where is that? I think I've done a mistake, because I realized that, no, it's 2 and minus half. So 2, which means x equals to 2, and minus half, which means this one. It doesn't cross to the x-axis again. And if I find the stationary point, of this exact thingy. It's 7 and 25 by 12, which means it's supposed to be, oh, it's 7 and 25 by 12. So it's not here, it's very much towards the right. And something like this. So yeah, actually I was thinking why my graph is wrong, but now I feel it should be okay. Is it? 7 and 25 by 12. So it means it is supposed to be 7 and 25 by 12. Actually, this feels a bit odd to me because it's supposed to go to the axis once, but according to a question, we get twice. Something a bit larger that can actually also go through the curve like this. But yeah, actually it does go to the axis. The only point of using this asymptote is for this little guy right here. Otherwise, this is supposed to be my curve. This is minus half 0. This is minus 2, 0, 0 minus 2. This is 725 by 12. This is 2, 0. And this point, which goes to the asymptote, happens to be something different. Uh, okay, you know what? Actually, it doesn't go through like this. It goes through something like this. In fact, I'm going to verify this using my Desmos just to make sure that it is okay. So it tries to go through this one, but it doesn't. The only point of intersection is this one. So I'll use my Desmos now to check the answer. If I sketch the graph right now, y equals 2, what do I have? 2x squared minus 3x minus 2 by x squared minus 2x plus 1. Yeah, actually, wow. Actually, it kind of looks the same as my graph. All right, if I go back to mine, I tried to make my point here. Let me show you. Look at this. This part is correct. This part is entirely correct. This part, I don't think it really matters if you actually make this mistake, but if you do make this mistake, you would still get a mark because you're not actually um, destroying the whole shape of the graph actually. If you accidentally do this part here, you're not this I mean you're not contradicting the fact that there's only one intersection with one stationary point and only one positive y-axis intersection. You're not defeating that case here. So it still works. So yeah, my graph is finally correct, but I had to make some things up because this is also my first time trying to deal with this one. So if you have anything that goes through like this, also check if there's intersection with the asymptote as well. I felt like there would be because if I put here y equals to 2, then I would have this going there. This would become 2x squared there. This 2x squared and this 2x squared would cancel over, something like this. So these two would cancel over. We would have x equals to 4. So it means there is still an asymptote intersection. This asymptote is just really a meaning for this part of the curve to go through like this. going through this little portion right here, going to these two parts, and then there's this vertical axis, meaning for this one and this one there, which actually still keeps going over there, but it does not cross through it does not intersect the asymptote. That's how things work here. All right. So yeah, this is this question.